Hello everyone, let's take a look at our next problem. In the expansion of ax plus b to the power of 2000, where a and b are relatively prime positive integers, the coefficients of x squared and x cubed are equal. Find a plus b. Okay, so my first thought here is to, use the expansion of a binomial, like is it called the binomial theorem, where the coefficients are these combinatorial things, and that should allow us to write down the coefficient in front of x squared and in front of x cubed. Those will be functions of a and b with some other combinatorial terms in front of them. We're going to set them equal, and we may not be able to solve for a and b directly, but we're only asked for the sum. We might be able to solve for a and b directly. I'm not sure. So yeah, I think that's my first thought. That's what I'm going to proceed with, and hopefully I get something meaningful out of this. So by proceeding with what I'd said, right? I've just written this in terms of a general exponent rather than the number 2000. But this is the coefficient in front of x squared. This is the coefficient in front of x cubed. I've set those equal and simplified this expression or this relation as much as I can. And I end up with b is equal to 666 times a. But now I want to use the fact that a and b are relatively prime positive integers. I'm a little bit confused now because I don't see what is stopping us from having multiple different values of a that would work here. Like if I let a be equal to 5, then a and b will be relatively prime. If I let a be equal to 7, a and b will be relatively prime. I feel like maybe I should redo this computation. Maybe I made a small mistake in the arithmetic in simplifying this expression. So let me go ahead. Let me go back and redo that quickly. Okay, so I think there is an additional piece of information to solve this problem that's needed, which is not actually given in the question. So this problem is taken from the Amy mathematics contest, where all answers are positive numbers between, I believe, 0 and 999. So this puts restrictions on how big a and b can be, because a plus b is not allowed to be greater than 999. So we can see right away the smallest that b could possibly be is 666. If a is not allowed to be equal to 2, because then a and b are not relatively prime, the next smallest possible value of a that would work would be 5, but then b is going to be significantly greater than 1,000. So in fact, the only possible value for a here is 1. So I forgot about the fact that answers had to be restricted to be less than 1,000. So with that last piece of information, the bound on the possible answer, we get that a plus b is equal to 667. Pretty confident in that. If I find an error or if I have some additional thoughts, I'll put it in the description. Otherwise, thanks for watching.